Good morning. Thank you so much for joining us here at the LA Times Google Plus Hangout. We're here with Joy Crisp. She is one of the leaders of the Mars Curiosity mission, and she's here to talk to us a little bit about Curiosity's first Martian year. That is actually 2 Earth years, given that the Martian year actually is 687 days. So this is the point at which it has now experienced all 4 seasons on Mars and has completed a revolution around the sun on the red planet. Joy, thank you so much for joining us.
Sure, it's great to be here.
So how does it feel to have completed a whole revolution around the sun on the red planet?
Oh, it feels so great because this was an important milestone that we set for ourselves to make sure that we could last this long. And now we're looking forward. It's in good shape, so we are looking forward to getting over to Mount Sharp and continuing to live.
Very cool. So this rover was the most advanced robot we've ever sent to the red planet. Could you tell us a little bit about it and what its capabilities were and what it set out to do?
Yes, you're right. It's a very complicated beast. It's the size of a Mini Cooper, and we loaded it up with 10 science instruments, some that are very big, that are inside the body of the rover. We added a drill, which is the first time we've ever sent one to Mars and robotically drilled into rocks. It has a scoop. It has a laser that can fire at soil and rocks. A whole array of things to interrogate the rocks and soils around on the surface and to do basic geology and to characterize the environment of Mars. And the whole point is to try to figure out were there environments suitable for microbial life in the past or even possibly today.
Yeah, so over the past year, it sounds like Curiosity kind of hit pay dirt, right? It dug into the surface at Gale Crater in a particular place called Yellowknife Bay, and it found chemical signatures that show it could have been a place that was friendly to life, right? So you guys hit the jackpot early on. What do you do with that, and where do you go from here?
Well, we breathe a sigh of relief that we really were lucky. So where we landed, we didn't make a beeline for Mount Sharp. We said, look, over there, just 5 football fields away to the other direction is some interesting rocks. Why don't we check those out? It's our last chance to do so before we head over to Mount Sharp, and let's see what we find. And we did find lake bed sediments, mudstone rock, that we were able to drill and then analyze and determine, like you say, that there were the chemical ingredients for life and that the conditions when those rocks formed were suitable for microbial life if life ever was around back then. So we also were able to age date some of those rocks. So it was very exciting what we accomplished, more than we had even expected for that area. And so now we've turned our attention to Mount Sharp, where we have a thick stack of rocks from older at the bottom to younger as you go up, and we can see from orbit that there are interesting minerals and that there should be changes in the past environment that we could try to work out if we can get over there and drill the different rocks and analyze them.
Yeah, so Mount Sharp was always the main goal for you guys, but how often do you guys sort of have to deviate from a plan or say, forget it for a second, we're going to try something new? And I mean, does that feel like a big risk when you do it?
Everything's a risk. Every day where you're making a decision to drive on or to stay put is a choice, and it's a trade. So we wrestle with that every day, and all these rover missions are similar in that tension of deciding where to go, what to do with this precious asset. So right now we're in a mode of having a lot of pressure on driving and not stopping and studying every interesting looking rock along the way. And we really did get support of the full team to want to do this. So lately we've been driving very efficiently and doing a little less science with our eyes on the prize of getting over to Mount Sharp as soon as we can.
Yeah. So over time, I mean, you mentioned that you're sort of trying to make sure that you treat this precious resource, this really, high-tech robot that we have well, but I mean, there's only so much you can do, and you got to learn on the job as well. So Curiosity experienced a little bit of wheel damage, right? That was not expected. why was that unexpected, and how do you deal with a situation like that when it comes up?
Yes, so that is something that we're very adept at doing at the Jet Propulsion Laboratory. Is our engineers are used to uh, encountering issues that were unexpected, and then working through how to get around those issues as best you can. And so this was a surprise to us that well into the mission in late 2013, we discovered by looking with cameras at our rover wheels that there was a fair amount of damage, and that the rate at that period of time was quite high of punctures of rocks puncturing the wheels. So we slowed down and investigated this quite intensively. And through a combination of engineers studying it and scientists studying, we came up with a very good solution, which is a much more sophisticated assessment of the pictures from orbit as to where to drive, where will we minimize the damage to the wheels, as well as how to drive differently. So we're doing a lot of backwards direction driving to minimize the wear and tear on some of the wheels. That and more clever short-term driving techniques are really lowering the rate of damage to the wheels. So we're now feeling like there's not going to be a problem getting to Mount Sharp. But you never know when we go into new rocky terrains what we'll encounter. What happened through testing, we determined that we simply encountered some terrain where there were very sharp rocks firmly embedded in the ground, and that the pressure on the wheels was enough to puncture them. And we had simply not done testing with that configuration of such severely pointed rocks embedded in a ground before, and now we have run a lot more tests on that kind of configuration.
Very cool. So it sounds like you guys are sort of picking your paths more carefully, sort of looking at the photos and the images in different ways. And you're also going backwards. You're doing the moonwalk on Mars, basically.
Yes, we are doing more backwards driving, and that's a choice that one of the tools that the drivers can use, and they have reasons for why they might or might not drive backwards on a given day and a given stretch, but they're using that more and more.
Very cool. So we have a question from John Miller on Google Plus, and he says, "How long will Curiosity remain functional on Mars?" I mean, you've basically passed the Earth 2-year mark, which is Mars 1 year, which was the primary mission. How much longer do you think we can go from here?
Well, there's nothing where we can say for sure how long it will go. We've just submitted a proposal to NASA for extending the mission another 2 years, and that looks very, very feasible. And probably another few years after that. But each 2 years, we're going to re-examine what is the health of the rover at that point to understand what its expected lifetime might be.
So the predecessor to Curiosity, one of them, Opportunity, which was this tiny, adorable solar-powered rover, had some problems, correct me if I'm wrong, in winter because you couldn't get enough energy to keep going. Are there any particular seasons that are really difficult for for Curiosity to face?
It's not as difficult because we use a radioisotope thermoelectric generator for our power that isn't affected by the change in the sun like Opportunity rover faces. So, but we do have a harder time in the winter because we need to use our heaters more to get the motors up to the right temperature to be able to operate them. And that takes energy. And that means we have less energy to carry out science tasks or for driving and things like that. So the kinds of motors that we have to heat up are the wheel motors and the mast motors, the robotic arm motors, all of those.
So has your relationship with Curiosity changed over time? I mean, you've really gotten to know it, I guess, over the last 2 years. Is the way you feel about it back then when it landed in that dramatic landing changed?
Well, it certainly does. one of the funny things is it becomes routine. I know that sounds strange that operating a Mars rover could become routine, but it does. After you get in the groove for a couple of years, you just think, okay, that's normal that I got new pictures from Mars today. But it is true that we do get surprised, and that's the fun part of the mission, that every now and then we'll see something pretty amazing and go, ooh, look at that. You know, it's either really beautiful in the scenery or a strange new rock that we ponder, and that makes it really fun.
What is it like to manage or help manage a team of hundreds of scientists? Because scientists are sort of very, very independent thinkers.
Right. It's quite a challenge. We have methods of doing operations that we inherited from first the Pathfinder mission in the late 90s and then the Spirit and Opportunity missions. They formulated ways for the team to work and to work especially for Spirit and Opportunity, to work from all over the world using the phone and their computers, and organizational schemes to bring the science team to consensus on what the rover should do tomorrow under a tough timeline, and also to make longer-term strategic decisions like this one where we got the science team together to talk about, hey, maybe we should drive more expeditiously to get to Mount Sharp sooner and do a little less science along the way, and came to an agreement. But it does turn out being kind of like herding cats to get those kind of decisions made.
For sure. Yeah, because you're trying to make a beeline now, but are there any folks who are like, well, there's some interesting rocks over there that I think we should check out, or let's just check out that interesting scarp over there just for a minute. It won't take too long. Then we can head straight to Mount Sharp. Do you have to deal with that?
It happens every day. It even happens to myself or the people that have made that decision. It's human nature. It's very much like when you're going on a vacation trip and you're trying to get to some point, and then people see something interesting going by on the road and say, hey, let's stop. It's that same kind of thing. So it just takes compelling reasons, and you have to keep reminding yourself that you have some objectives that you need to meet, and so the team has to remind itself constantly about those goals, and then get back on track.
Very cool. What do you guys expect to find when you reach your next destination? Actually, what is your next what is the next point before Mount Sharp, if there is one, and then how long to Mount Sharp?
There, we want to see the terrain, the geology as we go along quickly. We might be able to stop and take a few drill samples for the chem-in to analyze, just get some more mineralogy. And then the next big stop would be presumably Murray Buttes, which is at the base of Mount Sharp. There's a unit nearby also that's called the Paintbrush Unit, one of the first rock units at the base. We don't know what we're going to find there, so it really is a mission of discovery, and it's even possible that before we get to Murray Buttes, we might find something that causes us to stop and want to analyze because it's intriguing.
So you're keeping your options open.
Yeah, we really have to, because we can see so much from orbit, but we can't see the details that we will see in our pictures that come back from the rover.
Mm-hmm. And now that you've found a life-friendly environment in Yellowknife Bay, what do you hope to find in these other places? Do you hope to find environments that looked entirely different? They could be a totally different type of environment, the way that Earth has lots of different types of places where living things can live? Or are you hoping to find maybe more of the same so that it shows that, well, this was a little oasis, but it was the same here, and so it could mean that this entire area was potentially life-friendly?
We would really like to get a better understanding of the environmental conditions in the past as a function of time. And we have clues from orbit that there will be some changes as we work our way up through to the younger rocks, but we're not sure what we will find. So we are kind of hoping that we'll see changes. We also want to learn which kind of rocks or past environments are better for preserving evidence of past life, and can we encounter any that actually have abundant organic molecules measured with the SAM instrument on board. So far, we haven't seen much. So that would be another thing we're on the lookout for.
Okay. Now, you are a woman in a position of leadership here at this really huge mission, one of the flagships for the JPL Mars program. I mean, how is it being a scientist and a woman in this field, and how do you hope to encourage other women to potentially join it as well?
So I'm hoping that I can serve and other women on the project can serve as role models for young women who might be interested in math and science and engineering, and they may not realize that there are fascinating jobs that they could hold on this kind of a mission. So actually tomorrow, Thursday, June 26th, we're having what's called Women's Curiosity Day, and we're staffing as many women as we can in the operations roles. So normally with the whole team, we have 27% women. So that would be a typical ratio on a given day operating the rover. But tomorrow we're going to have 75% of the roles filled by women. And it's just a fun thing to do for the team, as well as then showing young women and girls that might be starting to be interested in math and science, hey, look, the kind of jobs you can have, which are everywhere from the highest level of management to interesting things working with the maps or looking at the geology or doing engineering checks of the rover and how it's doing.
So you were a geologist starting out, right? Which, you know, you tend to study Earth rocks first. I mean, did you ever imagine that you would end up studying rocks on another planet? Was that something you expected to do?
Not at all. So that's another interesting thing for young women to realize is that, you know, if you learn these tools of engineering, basic math, engineering, and science, you never know where your career will lead. I didn't even know I was going to end up being a geologist until I got into college in my second year. That led me to study volcanoes, and then I accidentally ended up at JPL, the Jet Propulsion Lab, working on Mars. So it wasn't something I expected to do, but because I had the right background in education and skills, I was able to take on this job.
Very cool. Well, I think those are pretty much all of our questions here. Thank you guys so much for joining us for this chat with Joy Crisp. She is Deputy Project Scientist for the Mars Curiosity rover. If you have any other questions, please feel free to tweet them to @AminaWright, and you can also email them to our folks at latimes.com. Thanks again. Have a great day.